Hello. Okay. Just to make some clarification, I'm not Raf, but okay. But he's going to speak to you in a moment later. So anyway, good afternoon, ladies and gentlemen. Thank you for having us today. My name is Isaac, and together with Raf, we'll be speaking to you about cementing Malaysia's futures. So we all know that the construction sector contributes 5% of carbon emissions worldwide. With rapid development and increasing urban population, people migrating from rural to the urban areas. So development is something that cannot be avoided. So this is resulting in a huge increase of CO2 emissions in our cities, not in Malaysia, but all over the world. So the question here is, how do we cut down CO2 emissions, and what are the alternatives that we can use? I call this to co-process cement and create a sustainable, cement futures. So before we go into further, so I would like to share with you that some data and stats where we stand currently. Okay, so here it shows that Malaysia currently regenerates about 33,000 tons of solid waste every day. And this data actually is 2012. But the latest one that I got is 2017. Currently, we generate about like 38,000 solid waste every day. Scary, isn't it? So the thing is, I want to point out how do we make use of this waste to co-process in the cement. If you can see, organic waste is forever the highest one, which form 45% out of this pie chart. And plastic forms 13%. So here, as per 2017, the recycling rate in Malaysia stood at 17.5%. If we look at the metric tons we generate every day for plastic, it's about 2,850 metric tons every day, again. So this is a huge number. And I want to show you this table. This is not something that we should be proud of, but anyway, Malaysia, we ranked number 8 in ocean plastic pollution in 2015. So we are not number 6, apparently. Okay. So if you can see that the waste generation generated rate kg per ppd is actually 1.5. It's much higher than the top 3 countries in this table. Okay? So, we face different challenges in addressing plastic pollution. But some of this actually has been mentioned during the previous speakers. I want to point out that human is a main generator, or I call it as a top culprit. We contribute to the plastic pollution, be it on the land or on the ocean. So why is it? I guess maybe we have a low awareness towards environmental issues. People tend to think that this is not something very important, okay? So they tend to take it lightly. And attitude. I guess we have been, in Malaysia, we have so much of awareness program and initiative going on for the last 10 years. But the thing is, it's very hard to change, especially when it comes to segregation at source. Even though we have, be it at the federal level or state level, the government has been promoting so much of this kind of initiative, but the result wasn't really fantastic. Another way, enforcement, I think this one, it's most critical. People tend to be not afraid when there's no bold enforcement. There's no bold enforcement take place, and to the business owner, I'm not saying all of them, but some of them, they tend to behave with this attitude. We just do it just enough to comply with the regulations. And last but not least, I think this is a thing that we lack in Malaysia here, with a sophisticated infrastructure, like right from collection to transportation and eventually dump the trash at the landfill. And this one is certainly, I guess just now, Maida has given a very good incentive. Hopefully in the next 5 or 10 years, we can see a very good infrastructure in Malaysia here. So next, some question to ponder. Do we really need a very good infrastructure first to tackle this plastic pollution, or we want to educate our kids since from small? So think about it. So next, Raf will be going to speak how co-processing could help to reduce waste as well as to produce a greener and sustainable cement.
Thanks, Isaac. Countries around the world who've already implemented a plan for the cement industry to be part of the elimination of waste that basically is at end of life. So there's no further uses of that waste. The ideas we've seen here today are incredible, turning it into new products, turning it into recycle, upcycling, and of course into a type of biofuel as well. Germany, UK, of course, India has recently in 2017 put together a plan for waste being put into the cement kilns. So it's become a accepted form of elimination of end of life for waste. The co-processing in cement kilns can be put in at several different stages: the preheater, the calciner, the main burner, and of course at the blending stage as well. And this accounts for all sorts of products like fly ash and plastic waste and gypsum. Different temperatures at different levels. So you've got preheater, which is a lower temperature. Then you've got the main kiln, which is over 1,400 degrees. So very high temperatures to eliminate dioxins, other harmful chemicals, furans. Those type of chemicals cannot be eliminated through incinerator, and they certainly leach into the landfill sites. So the leachate from the landfill site still contains the dioxins and some of the chlorides as well. So hazardous waste, for instance, hospital waste, municipal solid waste that has been incinerated, the ash derived from that in China and Japan is also classified as a hazardous waste, and you get a tipping fee for incinerating further the ash from a municipal solid waste incinerator in a cement kiln, because it basically eliminates all the dioxins and other harmful toxic substances. I'm not sure you knew that we were having a discussion in KL the other day, but airlines. So airline trans-border waste carried by airlines from one country into another is also considered a hazardous waste. So there are numerous areas where hospitals, airlines, and other types of waste need to be completely eliminated. And municipal solid waste can be processed further into a RDF, refuse-derived fuel, or even a PEF, processed engineered fuel. Used tires, which we've been using in our cement plant as an alternative fuel, but also eliminating a source of waste, basically end of life, because it's very difficult to devulcanize rubber, even though it's been tried on a good scale here in Malaysia. It is incredibly difficult, and it's a chemical process which requires a lot of energy as well. Industrial plastic waste, consistent type of substance which is easily fed into a cement kiln, so long as the chlorides are not high. So PVC, polyvinyl chloride, doesn't sit well in a cement kiln, but otherwise all other types of plastic waste can be burnt in a cement kiln. Sorry, this is not working. Oh, there we go. And Then we come to the types of alternative fuels which can be used basically as a thermal substitution rate enhancer. So rubber tires have a calorific value of roughly 8,000 or 9,000 kilocalories compared to coal, which is about 3,500. And there's all types of other industrial waste. We don't use all of those, but we certainly use some of those in the cement kiln. And that reduces the carbon emissions because you're offsetting the fossil fuels and also burning a waste product in a controlled environment with particulate filters with a limited amount of particulates flowing into the environment. Also for the slag cement, when you're actually blending cement, which YTL has been doing since '97, you're talking about fly ash, blast furnace slag, copper slag being used. We don't call them waste products, but they're byproducts from different industries. So they can be used in the cement industry to enhance the strength of cement. And these have been used in a number of different projects, Sentosa Resorts World, the TRX project, the Twin Towers, very many projects for very solid foundations, hard setting concrete. And of course, these are the examples that YTL has used directly, MRT Tunnel, Penang Bridge, and of course, the TRX main tower. And of course, M-sand comes, it's not a byproduct of an industrial process, but it's a byproduct of a quarry that can be used, and that's also been used for the TRX. 100% of M-sand was used in that project for the main tower at the TRX project. So that is also what would be a waste product converted into a substrate for concrete. And then waste heat recovery, this is not dealing with a solid or liquid waste, but certainly this deals with another waste product. So we have a China plant which produces about 8 or 9 megawatts of power from waste heat. And in Malaysia, we've now got a plant which is about 9.5 megawatts from waste heat. So again, that would have been burnt in the environment with no productive use, but a Danish company has now come out with a drying process using the waste heat from cement kilns as well to prepare other fuels from the municipal solid waste stream for a alternative fuel for cement plants. And of course, coal-fired power plants, that's where the fly ash and bottom ash come from, so there's further uses for those as well. And I think that in this case, fly ash we buy from Tenaga National in Malaysia. Again, that would have normally been landfilled, but we divert from a landfill. So what is the circular economy in terms of what YTL has experienced? Wessex Water has a subsidiary called Genico in the UK. So we collect food waste, about 45,000 tons a year. And that food waste is then digested in an anaerobic digestion facility, producing biomethane. Biomethane is used then to run the trucks that collect the food waste. So this is a good example of a very strong circular economy model where food waste, which as you probably know represents about 30% of the waste that normally comes from supermarkets or restaurants and homes, again is recycled into reusable product in terms of energy. And of course, plastic waste is not just limited to the areas we've seen so far, but we've heard about the Eco-Arc in Taiwan earlier from MiniWiz, and the building blocks, I think that Doug mentioned in South America. And of course, in UK, it's a substitute for making asphalt from, instead of using bitumen at 10% substitution rate, you can use it at a much lower rate of about 1 or 2%. So a very strong substitute there as well. So these are just the other examples. For our vision, CO2, I know Doug says we should separate some of those. You know, CO2 is one issue, recycling is another, and of course, reducing dependence on fossil fuels is another area. But all these combine in the cement industry to create a circular economy and our vision for what we see as an outcome. Perhaps the model can be developed, but it has to be in cooperation with government. And the private sector is very keen to move forward on this. So I think it's a very strong potential for end-of-life products in this area. Thank you very much for your time. I think I'm out of it as well.